Hello everyone, welcome to another session of Circuits and Networks. In today's class 2 under three-phase system or three-phase circuits, we'll see the power relations, the impedance relations and simple problems involved with three-phase circuits. So in the last class we have seen the delta and star representation in diagram form, in phasor form and the outputs what we got for three-phase circuits. Let us go with the problem. First, let us derive the relation between power in star and delta systems, especially for the balanced system. So, for a balanced star network, the line voltage and line current are given by VL and IL, and V phase is given by VL by root 3, whereas I phase is given by IL. So, in star network, what we need to remember that the line current and the phase current are one and the same, whereas the phase voltage is equal to line voltage divided by root 3. With this, I can easily get the impedance in star form as V phase by I phase, replacing the values of V phase and I phase in line voltage and line current form. So I'll get VL by root 3 IL. So I'll treat this equation as 1. Similarly, for an equivalent delta connected balanced system, if the line voltage and line current are given by VL and IL, then the phase current is given by IL by root 3 and phase voltage is equal to the line voltage. Then the impedance in delta will be equivalent to root 3 times VL by IL. In fact, when I'm going to substitute the value of root 3 in terms of star impedance, so I'm going to get impedance in delta which is equivalent to 3 times of impedance in star. If at all I take this equation as 2, then I can frame the equation as impedance in star is equivalent to impedance in delta divided by 3. Let me treat this equation as 3. Now what we have remembered, for a balanced star connected load, the line current and the phase current are equal, and when you substitute actual value of the phase current, this is nothing but V phase by Z phase. In fact, change it to line form, so it becomes VL by root 3 Z phase, and the power calculation we have obtained as root 3 VL IL cos phi, substituting the value of root 3 VL as it is, whereas IL is equal to VL by root 3 Z phase multiplied with power factor cos phi, which will give us the value as VL square cos phi by Z phase. Let me treat the equation as 4. What we remember, for a balanced delta connected load, I phase is equal to IL by root 3. So I'm changing the terms of I phase in terms of VL by Z phase. In fact, I can get the value of IL which is equal to root 3 times of VL by Z phase. Treating this equation as 5 and remembering that V phase is equal to VL for balanced delta connected load, we can derive the relationship of power in delta which is equal to root 3 VL IL cos phi. Just substitute the value of IL which is nothing but root 3 VL by Z phase cos phi. In fact, it becomes 3 because root 3 becomes 3. You have VL repeated twice, so VL square cos phi Z phase. So by equation 4, I can change this value equal into 3 times of power in star connected load. So we can easily obtain the relationship of power in star equivalent to power in delta divided by 3. So this we are reading as equation 6. Hence we have obtained impedance relation and power relation in three-phase circuits for balanced load. If we go with the problem, you can look at it this question 1, where we have 3 equal impedances of value 3 plus 4 j ohms. It is given in rectangular form, are connected in star form. This arrangement is connected to input supply 415 volts 50 hertz 3-phase supply. What we need to calculate, the phase and line voltages, active and reactive powers. So we have to recollect the information what we have gathered for balanced star connected load. First take the data. The data is given as impedance, line voltage and frequency. We know that for the star connected load, V phase is equal to VL by root 3 So VL is given as 415 divided by root 3 gives you the value as 240 volts. So the phase voltage is obtained as 240 volts. So impedance in rectangular form is 3 plus 4j. I can change it to polar form as 5 at an angle 53.13 degrees. So that the magnitude of impedance is 5 ohms. The phase angle given by 5 which is equal to 53.13 degrees. Now I phase is equal to B phase by Z phase. 240 by 5 will give you the value as 48 amperes. In fact, line current and phase current are equal in star network. Hence, it is easier for us to find out the active power given by P is equal to root 3 VLIL cos phi. Substitute the value of VLIL cos phi value, that is 53.13, will give you the value as 20.701 kilowatts. So this is the active power. The reactive power is given by root 3 VLIL sin phi. Substitute the value of voltage, current, and sine of phase angle value 53.13 will give you the value as 27.601 kilovolt ampere rating. So this is the active power and reactive power for the given problem. Now what if the same problem is given to us and the connection is in delta form? You can see the parameters are same. The impedance parameter is same. The voltage, the frequency and the three-phase supply given to the delta network are one and the same. Just we need to calculate the active and reactive power. For that, the information we have to collect from the given input that is in the problem. So Z phase value, BL value and frequency value you can easily determine from the given problem. B phase is equal to 415 volts because in delta network the line voltage is equal to phase voltage. So this is the change from previous problem to this problem. And impedance in polar form and rectangular form you can see the values where we have obtained impedance value as 5 ohms and phase angle value as 53.13 degrees, and I phase is equal to B phase by Z phase. So B phase value is 415 divided by Z phase is 5. In fact, the I phase value is 83 amperes. Now in delta network, since I phase is equal to IL by root 3, in fact IL is equal to 83 root 3 times. In fact, this value will be equal to 143.76 amperes. So line current is obtained. We know what is the value of line voltage, so we can calculate the power. That is the active power, which is root 3 VLIL cos phi. So root 3 VL value is 415. IL value we have calculated as 143.76 amperes. And cos phi is nothing but cos 53.13 will give you the value as 62 kilowatts. So this is the active power. Similarly, the reactive power will be root 3 VLIL sin phi. So substituting the values of voltage and current in terms of line, we are going to get the value of reactive power as 82.6 kilovolt ampere rating. So this is how we calculate the problems involved with three-phase circuits under simple category. So I hope you understood this particular class. Please share among your friends, subscribe to this channel, and please press the bell icon for the future notifications. Thank you.